Okay, welcome everyone. Welcome to the San Diego Kotlin user group. Today, thank you very much. We have Andy Goldberg talking to us about Kotlin APIs with flexible deployment options. Thanks for the talk, Andy. Take it away.
Awesome. Yeah, thanks, Ian. I appreciate it. And thanks to everyone for attending. I already feel a little bit bad, like Emily, who works on the Android side of things. Today, we're going to be talking about server-side stuff, APIs, and all that. But just being interested in Kotlin, I think at some point, and actually, that's on one of my slides, that people sort of migrate. They enjoy working with Android, and then when they're by learning it on Android, and then when they have to build a server application, they think to themselves, well, hey, Kotlin's a great language. Let me see what my options are there. So we're going to use a demo app that I built as sort of an example. But really the cool thing is with Kotlin and with a couple of specific packages, as you build your application, you will find yourself with a wide variety of options for deployment. And it turns out that like the JVM and Kotlin happen to give you a lot of choices and options and make it easy to decide where you want to go and how you want to build your application, even more so in some ways that of some other languages. So as far as the demo app goes, I'm just going to have you imagine that you are the proprietor, the owner of this hotel, restaurant, casino, gas station called the Border Inn, which is in a very isolated, desolate, lonely corner of northeast Nevada. Route 50 has been called the loneliest road in America. And this is right at the start of it. As you can see here, there's not a whole lot around there, although it is close to a national park, Great Basin National Park, which is probably like, I didn't even know that it existed until not that long ago, but there is a national park about 10 or 20 miles away. But anyway, so this application will help people find their way to this location. So right now you can see localhost 9,000. It's just running on my own computer, and I'm going to show how to push it out and get it working on a couple of different hosting options. So I do have a couple of slides here. This is me. Again, I appreciate all you guys coming. I know everyone's sort of after the holidays, sort of getting back into things and all that stuff. So taking the time out to listen to this I appreciate it. So in my experience, the people who build APIs with Kotlin tend to come from one of three camps. They're either, Java API developers, server-side Java builders. Some of them have been doing it for more than a decade or something. But then you also have a group of Android developers who, like I was just sort of saying, they start to realize they need to build something on the server side, and they choose to use Kotlin because they're familiar with it and they think it's a great language and all the advantages that go with that. And then the third group is people who have been building APIs with other popular tool sets in other languages, like Flask, like Django, PHP, and stuff. Personally, I'm sort of a hybrid of both of the last two there. I did a little bit of Android development, and that was my first intro to Kotlin, which I really, enjoyed doing. But also I had experience building APIs, especially with Flask, for a couple of different projects over the years. So when I moved to Kotlin, it was sort of relearning how to do some stuff. So when you do come from another language, or even from Android to server side, learning the language is half the challenge, but learning your development or deployment options and DevOps, how to actually get it there and get it all running, is another challenge that people sometimes sort of skip. They just focus on learning learning a new programming language without understanding really how to get it up and running. And so it is a little bit of a challenge. And it's something to be like aware of as you start building something in Kotlin. So the Java ecosystem, I guess, and I guess again, if I go back to like the first group here, they're probably super familiar with the concept of a class path, but the other two groups probably aren't, that don't have a lot of classic Java build experience. But the class path is where all of your program's dependencies reside. So, you build your code, but you are reliant on certain various packages and things like that, with a lot of functionality. In Python, we have what's called virtual environments, where basically they include the Python runtime, and as well as you install all your packages via pip into an isolated folder. Node has, this node modules folder, which is similar, like npm installs all the dependencies into this node modules folder. So that's sort of what the class path is intended to be in Java. But because Java has a compilation step anyway, you might as well have it like work for us and help us out with the deployment step going forward. One thing I'll just mention about Node is, especially today, even though Node is JavaScript and it's not a compiled language, almost all modern JavaScript needs a build step. So I'm not super familiar with React or Vue, but I build some stuff. I've been using a static site generator, which is React based. And you have to do a build at the end to, like, it uses Webpack, and it puts all your JavaScript into like a single file and renames all your images and like does size reduction and all that kind of stuff. But at the end of the day, you've done a build without getting the benefit of having like a compiled application or anything. So you sort of notice, kind of interesting in that you have this compilation step without really the main benefit, which is speeding up your code, which is kind of interesting. So the Shadow Jar plugin, if you're not already familiar with it, is used. It's a Gradle task that basically builds what's called a fat jar, which is basically a single file that contains everything, all your dependencies, everything that would be out there on the class path. And it just compresses it all into a single file, which is going to make deployment a whole lot easier. The problem with that class path is, like, where is it on your machine, on your server? You run into potential dependency conflicts where one program needs a certain version of something and another program needs a different one. Here, we just package it all together. So technically, a jar file, you might already know this, is actually a zip file. So if you have, any program that can zip or unzip, a typical zip archive, it can also unzip and see everything that's in a jar file. So basically, all you're doing is compressing everything into a zip archive, and it just has one file as opposed to having, directories of files and stuff. And it's super easy once you've installed it. Once you've, added the plug into your Gradle, you're just running a different function. Instead of a build, you're doing Gradle Shadow Jar. And the only thing that's not included, like in contrast to Python, where those virtual environments actually include the Python, compiler or runtime itself, your JDK is not included. That's the only thing, for the purposes of size, as well as, not you can already run your Java against a specific target. So there's no need to include it in the jar file. So I'll just show you real quick. Here's my Gradle file for this particular application. And you can, here's the plugin. You can see that my JVM plugin. Here's all the dependencies and stuff. And this stuff you should be familiar with, whether you're Android or server side, because they all use Gradle. And all I'm doing is adding this extra task right here. So really the only thing that's mandatory is just defining your manifest. I'm excluding, I don't want any configuration files. So I put an exclusion, and it'll come up with a jar file for you. But by naming it, I don't have to worry about like version numbers changing on me, and I know exactly what the file name is going to be. And then when it comes to compiling, I would have to do a build anyway. Now, like I said, instead of just doing Gradle build, I do Gradle shadow jar, and it creates an extra task that you can run it this way by double clicking. You can use terminal and just type it out. You can create a configuration and have it build that way. Obviously, you have a lot of different ways of doing it, but it's once you've installed the plugin, it's super easy. And yeah, we'll see it a little bit more in a couple minutes. So when it comes to deploying, you have multiple options, right? You can self-host with your own hardware. You can co-locate your hardware at a big, server location, something like that. You can rent a VPS at any of these providers, or there's plenty of others, especially if you want to. That's probably the least expensive option, the VPS. If you go to like low-end box, if you're familiar with that, you can find some very inexpensive providers. That you're on your own as to how reliable they are, but yeah, you can obviously go with serverless. Has been a popular deployment situation. Recently, the most popular is Lambda over at Amazon, but also Azure and Google Cloud both have their own very similar, you don't have to run any servers. It's just pure running functions. And then Heroku, which is sort of fallen out of favor a little bit, but probably has the easiest deployment setup of all. Heroku's really only downside is that it's pretty expensive. But if you're working at a bigger company or cost isn't as much of an issue, it still actually has a really good sort of story. It's definitely shouldn't be overlooked. So the cool thing is, the cool thing is we're going to have the ability and the flexibility to choose any of these options. We're not going to get painted into a corner by the tools or the dependencies that we're using. So the other question is whether to use Docker or Kubernetes. And then what about configuration details? You always have like these configuration files that may change depending on deployment, but also, that may change more often, that you want to adjust without having to recompile and redeploy your application. So just keep that stuff in mind. So in my opinion, by having the shadow jar create everything into a single file, that really lessens the argument for needing to use Docker. I know Docker's popular. It still is a lot of steps, in my opinion, versus just basically sending a single file to a server. So being able to work without it is a plus, in my opinion. And then, like I said, which platform to choose, we can remain flexible because of the dependencies, the tools that we're going to use for this particular app. All right, so yeah, so actually here, we're going to go into the code and we're actually going to see some of this stuff work. I'm going to go back to here. And so again, this is running on my local machine. This is what's in my IDE that's currently, you can see up here, it's currently active, currently running on port 9000, which is right here. So what the goal of this demo app is, basically, if I tell it where I'm at now, it's going to give me, it's going to go to a third-party service that does routing and drive-by, turn-by-turn directions and return that to me. So if I say, I want to know how to get to the border in from San Diego, it reaches out. It says you're 636 miles away and you're only a short 10.5-hour cruise. And then here's all the directions. You're basically riding on I-15 for a while, 215, more I-15, actually into Utah, and then coming back west a little bit. Yeah, interesting. So that's sort of the goal of this application. And I'm going to show how I've gotten it to run on a VPS, at Heroku, and at as a Lambda function, and how easy it is to decide and to move one way or the other. So the two key packages that allow me to do this, the first is called Hoplite, which is a configuration manager. And then the second one is HTTP 4K, which is my API server. It's what handles all HTTP requests and responses. So I'll talk about Hoplite a little bit first. So it's a GitHub project. Yep, right here. And it's cool because it has a lot of flexibility as to how you want to provide a configuration file. And it's also very good with understanding lots of types. And it's very Kotlin native. It gives you good errors if necessary. And it's just very easy to work with. So in this particular case, I have about 7 or 8 different configuration parameters. So I'll give you, here's my configuration file. And yeah, speaking of recording, I'm gonna have to edit some of this out. But I got a port number. I have this, the destination with the name of the place, the latitude, longitude. Here's my API key to that routing service. And then here's also my database credentials. So I could easily, sort of natively create environment variables for each one of those individually, right? But then I would be running around in my application with environment variable names in quotes, which is extremely easy to get wrong. It's also, and if it was incorrect or something was missing, it wouldn't be noticed right away. Like the program would compile, and then once running it, it would eventually realize, hey, wait, you never told me the API key. You spelled it wrong or something like that. Or, the program itself wouldn't know. All it would know is there's not a environment variable name, API key. So what Hoplite does is, first of all, it creates everything as a Kotlin typed variable. So it's not everything. It knows whether it's supposed to be a string, an integer, a date, whatever it might be. And then it's also, like I said, very flexible with how you import that stuff. So I create 3 data classes, one representing the API for the routing service, another one for the database, and a third one for the destination, the actual location of the place we're trying to arrive at. And then I combine a single app config variable or class, which is sort of a hybrid of all three. I have two new variables, a port number, and then a platform name. And then, my destination is the destination class. My database is the DB config class, and my geo is the geo API class. So again, everything is tight and things can be nested. So like the stuff within there is 2 levels deep. You can have defaults, but anything that you define in a config file will override your defaults and things like that. And then the first thing my application does is to try to load a valid configuration. And again, Hoplite is very flexible. It can read a file, it can read a string, it can read something. If we're going back and something's on your class path, it can read something from there. It's okay with JSON, it's okay with YAML, it's okay with a number of other configuration formats. So what I've done is it can read either an environment variable that's already in JSON format. It can look for a file as long as I provide it with the file name. And if not, it'll default back to just a config dev, which I keep, for running locally. So as soon as I start the application, again, that's the first thing it's going to do. If I have my config dev that, for example, I'm going to comment that out. So it's missing something. When I start up the application, it's going to fail, and it's going to tell me, though, exactly what was missing. All right, computer's a little slow.
And that's a feature of Hoplite that it's including?
Correct.
Validation? Okay. Exactly,
right. Once you define these data classes and then created, another class, which is the combination of the data classes that you've created, you don't have to go multiple levels deep like that. But once you have this app config, once you have a data class, and then you say you're trying to build it, and that's the class that you want to get at the end, then if it doesn't have if it's missing any of the parameters, then it's going to raise an error right away. Like I said, if you have a default value, obviously it won't raise an error. It'll use the default if your config file is missing. But like in this case, like I said, I didn't have a default for the API key. And so when I commented it out, it no longer exists. And it tells me right away, your API key, the geo class could not be instantiated because you're missing this parameter, the API key. Versus when I have it back in there and try again. Again, this is the first thing that my application does. So it's not going to compile. It's not going to start to run and then halfway through, or later on, which is especially important if it's like a feature that you're not using all the time. You find out during the runtime that you've been missing a parameter this whole time because it doesn't validate. This performs that validation right away, immediately. So, like I said, because I can load a JSON string or a file, that's going to give me a lot of flexibility when we move on to these deployment situations. But anyway, if you're not already familiar with Hoplite, I would definitely strongly suggest giving it a try in your next application. Almost every application needs some level of configuration. And I think this is a great package as far as allowing you to sort of do it however works best for you. Like I said, multiple different file formats. It already, it handles nesting. It understands lots of different types besides just your basic, string, int, all that stuff. It already understands collections and pair and triple, and it can create a connection pool just from a configuration file and other stuff. So like the author's, done a lot of integrating and things like that. So when I go back into the application, like later on in the program, when I need to make a API call myself, I'm using a hard-coded, statically typed variable here with the host name, also with the API key. So again, Kotlin knows that, it's expecting a string here, and you have all the benefits of the static, typing and all that stuff. It's not just a environment variable named API key, which, like I said, could be misspelled, all that stuff. And that also wouldn't let Kotlin know what it's expecting as far as types go. So this makes it work very smoothly within your application, and you get all the benefits of typing and everything else. Okay.
Where's the? I just didn't see it. The connection. I saw the builder returns your app config there, which you just defined a line or two above. I just didn't see, how does that config loader.builder looking for sort of a generic or type inference point, how does it know the app config is the definition of what it's building?
Yeah. Okay. Good question. I think that's here with the variable name of config is defined as an app config type. And that's what we define. That's the class that we defined just before it up here, which contains, like I said, a port number, a platform, and then these other three, classes within it. So if I told it I wanted to create a different type of class right here, then it would fail. Again, I guess I don't have a second one, but if I told it, if I had data class, X config, where it was just, let's say IP address, and let's just say it was a string. Okay.
Yeah, I'm just wondering how, when you call config builder and you go through that builder there, right? Add source,
right,
build, and then load, configure, throw. How does it know to return this app config from load, configure, throw? Because you just defined app config. I don't see it being passed into the builder anywhere. So how is the builder aware that? How does the builder make that the return value of that?
Yeah, I sort of see what you're saying. I think
maybe
it may be
cut off on the side of the screen there or something.
No, that's not. Yeah, it's. Okay. I think it when you define the type, basically this build and then load, configure, throw is making sure that it's able to return the type that you defined. Let me think if I go here. Maybe he explains it a little bit better. Okay. I gotcha. Here.
So it's a generic type. So that's the generic method. And
yeah. That's
that.
Right. So I guess technically I could do.
You don't have to put it there. Okay.
Right. That's a great point. Okay.
So there, and it's going to tell you you don't need to tell me this here because I already know, because you explicitly put it up online.
Yeah.
All right, that's the piece I was missing.
There you go. That's
they're doing some magic there, right? They're doing some
right. But no, that's a great observation.
Thanks.
Yep. Yeah, that's like the compiler hint telling you, hey, I already know that. I don't need to know because, Maybe if this wasn't here, then that would be necessary. Yeah. But yeah, no, that's a great question. But basically, yeah, I mean, it works, essentially, yeah, I've like forgotten about that because it works so seamlessly that, and it gives you that error if something is missing or is incorrect right off the bat, that you're not even thinking like, oh yeah, hey, I need to be specific on the type and make sure it matches, because it'll tell you right away if you have a exception or something. But
Yeah,
like I said,
really
then you can
slick.
take.
I might have to
What's
steal
that?
that idea. That's really slick. I might have to steal that idea. I
Yeah.
don't know. I just never thought to do that. That's pretty neat. Neat trick.
And then you have this universal variable, which is, usable within your entire application, which then, like I said, everything within it is typed, and you've defined these data classes, so it knows exactly what the contents of each nest or each branch of the, and you can go multiple branches deep, however you want to set up your config, or you could have multiple independent variables. I could have created, say, 1, 2, 3, representing each class, but that seems like I'd rather have it consolidated into one. So that's the config situation. Like I said, when we do the actual deployments, we'll see a little bit more about that. The second part, of course, is what tool you use to actually create the routes, to actually handling incoming HTTP requests and sending back responses. So one of the cool things about Java or JVM related packages like HTTP 4K, but it's also true of KTOR and I think some others, is that they are primarily used as servers, but they also have a client built into them as well. So like I said, in this particular application, I'm going to need to go out and request the turn-by-turn directions from another API. So do I need to load or rely on a separate dependency to make the HTTP calls? No. HTTP 4K will do both sides of it. It'll accept incoming requests. It'll also make outgoing requests. So it's cool in that sense. I'm going to go off on a second about HTTP 4K. I know I brought it up in previous meetups and stuff, and I've just mentioned I use it and stuff. I do like it. I think it's a great package, and it gives you a ton of flexibility because it can create different types of servers. It uses any kind of, say, JSON serializer and things like that. That being said, it's extremely powerful, and it's extremely well written. The two guys that are responsible for it are like geniuses, but in a sense, sometimes it feels like an academic exercise. Like everything is pure functions, and it sometimes make it hard to just do like day to day. Like I need to respond, with a certain way, or I need to attach a header to all these responses, and it's difficult to sometimes get the basics down. Whereas Spring or KTOR or some of the other options that are out there may make some of that stuff a little bit easier. In any case, basically what you're doing is just binding different routes. So, in the base case, I just have the generic no further path responded to a static message that I defined up here, which is what which is this page with the image and just a little introduction of what we're doing. When we go use these other paths, like the one I showed you to get the directions, basically you're binding the get method to a function. Everything in HTTP 4K is a function, either request to response or handler to handler, which is essentially a filter which modifies an existing handler. But basically, you're taking the incoming request and you're returning a function, or you're doing something on that request. In this case, we it uses what's called lenses. So it finds this piece of the path, which is defined here as, start, which that's what I used earlier from San Diego. So San Diego is my start variable, and that's what the lens does, is extracts your query parameters, or in some cases a post parameter or a header or something like that. And then you can run a function. So in this case, I run this directions handler function. And basically, yeah, I'm reaching out. I'm taking the place that was input. I'm reaching out now to this API service that's going to give me the directions and bringing that back. And then with HTTP 4K, sending that back to the original client. So I don't want to get too into the weeds of all that's working. This is supposed to be sort of simple and an overview and all that stuff. But basically, this is the routing definition. And again, if you use any other, package, if you use Flask, if you use Django, if you use Express, they all have some way of binding, routes to functions, to handlers. How do I, here I accept incoming request at this address, and now I have to do something with that. And they all, have the same thing. We all have to either pull out the query parameters or break down the body of a post, payload, or pull out headers, whatever it might be, and send back a response that your browser or API client can read. So that's basically how the program works. Now, the concept here is how do we get this deployed? Because running it on my local server doesn't do anybody any good. So I'm gonna show you right here that this is a VPS that I have running, and I have the application running from here. This is, you see Amazon AWS. This is a Lambda function that's running the application. And then here again is Heroku that's also running the application. So the first thing I'm gonna show is, like I said, to build the application. So I'm going to make one small modification. So you see right here, as it stands right now, it starts with the border in demo application. I'm just going to change that so you can see, border in demo application, whatever change I wanted to make to the program. So I can make a new build by executing my shadow jar task. The other thing I'm going to do is I'm going to make a new commit, and I like to use this source tree. Gotcha. Yeah. So I'm going to do a new commit right now, which is going to get pushed. So we'll see why that's important in a minute. And that should automatically push up. So my code is hosted at GitHub here. So that should be pushing it up as we speak. This compilation is usually only takes a few seconds, but here we go. Okay. So like I mentioned with Shadow Jar, I just have this one single jar file. I don't have like a whole pile of dependencies and a whole directory full of all the different packages I need. It's all wrapped up into this jar file, as you can see, 730 tonight. And like I said, it's just a zip file, like I said. So if I was not using Shadow Jar, I would have like all of these folders and all of these classes to put on my server somewhere. And like I said, I'm not a classic Java person. I don't even understand it all exactly, like where it goes or where by default, my server is, the location that's going to look for, as well as just like the hassle of making sure you get every single file uploaded precisely. Instead, I can just take an SSH, this is my SSH program, open up an FTP window, and just upload my new jar file. Oop. Yeah, overwrite. And obviously there's like command line to do it like automatically, even make it even simpler, or probably there's probably even like a Gradle task you could probably integrate that would like upload it automatically for me. But yeah, it's just uploading that one single file and then basically, restarting. If I hit Control C, and then restart. So I'll just mention when I start the application, I'm running a Java command, and the only variable that I have to pass to the runtime is where to find my configuration file. Again, if I had raw parameters for each individually, I would have like 8 or 9 of these, D parameters every time I wanted to start the application. And it would be less secure, it'd be much easier to make a typo. Here, it's just like one shot and everything is in that file. And it's starting at port 9000 again. And so now if I go back to my VPS and reload, yep, it's got the SD user group. So that means, the latest version is online. So obviously that is just a superficial change, but if there was change to actual functionality, and moving from version 1 to version 2 or something, it would all be there. And it's as simple as that, getting it deployed. Now you'll see here I have a very ugly, URL and insecure. Again, this is like just a demo app. I would put a real web server in front of it, like Nginx or Apache or Caddy is actually extremely simple to set up, and it manages lets encrypt certificates and re-registers them automatically. So that's kind of my preference right now. And you could use your DNS server to CNAME and make a real, a nice URL. As far as my configuration parameters, because I'm using VPS, I can do things real quick. I'm going to bring this over. If I go so if I wanted to run this on port 80, so I didn't have the port, all I have to do is change the config file. Okay, now change a config file. Again, I have to restart and rerun this. But now if you can see down here, it tells me it's starting at port 80 because I just changed the config file. So now this URL is not going to work. But port 80 is my default port, so it works fine on that. So obviously I could change other things in the config. We could, instead of doing the border in, pick your location. As long as I have a latitude, longitude, I could, use this same, structure for any location anywhere. So VPS is simple to begin with. And if I wanted to, I could probably make it even easier using some sort of continuous delivery pipeline that would automatically upload my new jar file and any other, restart my service and all that kind of stuff. But that's your responsibility when using a VPS. It's like you have total control, but you also have total responsibility to make sure, that it's working, that it's running 24/7 and all that stuff. Like I said, you have a web server, and in a real application, you're going to have database, maybe on the server itself or a third-party service, something like that. But okay, now I'm going to show Heroku. So Heroku is super cool. Because they manage the server for you. You really only have to get the code to them. In fact, they are already integrated with GitHub. So they basically create a pipeline for you. So if you see here, my deployment method is already connected with GitHub. So it's connected to my repo there and automatically deploys. So given that it was already a few minutes ago that we made our new commit and pushed it up, if I go to the Heroku app, it should, if I reload, yep, it's got the latest version as well. So it did that automatically. I didn't have to touch anything. And that's kind of why I say Heroku has maybe the best deployment story, because once you set it up one time, it's all set and ready to go. Heroku is interesting because it actually performs the build on its own server for you. So it is not taking like my compiled jar file. It's taking it straight from the repo. And all I have to do is tell it, I think it's in settings here. Yeah, config vars, right. So I have to tell it what the Gradle task is. In other words, instead of telling it to build, I'm telling it to use that shadow jar to create that single jar file. And then the issue with Heroku is that I can't have, like I have on my own VPS, I can't upload a separate YML file or any kind of JSON config file or anything else. I don't have access to their file system. So again, this is where the flexibility from Hoplite comes into play, because again, it's not reliant on just a file. If you want to just pass a JSON string, as long as it has all the keys, that's fine. And that's exactly what I did. So I basically just converted my YML into a JSON string, put it here on Heroku, and it's all right there. Now, one thing that's missing is a port number. And that's because Heroku isn't allowing me to choose a port. It's going to decide what port it's going to run on. So anything I put here would essentially be not just ignored, it would actually like cause an error, because now you're trying to tell it to run on a port that Heroku doesn't want to run on and all that. So, but all the rest of my stuff is right there in the simple JSON string. And like I said, once I've uploaded those two things, that's essentially it. And it runs, deploys. Here's a list of all, builds and stuff like that. They just all do it automatically. I guess, here I had to define um, the command line to get it running. But again, so that and the variables and setting it up in GitHub, that's it. That's all you have to do. And so it's very simple. HTTP 4K is still responding to the API requests. So it's able to handle both environments, no problem. Like I said, Hoplite is also flexible enough to use a file, use a JSON string, and build the configuration correctly as well. The third scenario I want to show is Lambda, because that probably is the biggest difference. When you set up a Lambda function, it really is a pure function. It's not connected to any HTTP anything natively. You have to create a trigger using their API gateway, which responds to specific get, post, request, and all that stuff. And then that gets passed on to your function. The problem is the gateway is actually converting the raw HTTP request into a sort of proprietary format. So this is sort of an example of what it looks like. Like, this is no longer just a simple GET request. It's given me like a JSON string with, it's already pulled out the string parameter, the query parameters. It's already pulled out what the path is. It's got all these other headers, some of which are relevant, some of which aren't. This whole request context, which, perhaps is useful and stuff. But the point is, my server built into the application isn't expecting a JSON string with all this stuff. It's expecting just a raw HTTP request. So this is where HTTP 4K shines, because instead of having to somehow parse this this whole JSON massive object, it's already built in to handle all that stuff. So here I add this extra class called Gateway Listener. I call it anything I want. And as you can see, the type is an API Gateway Lambda function with my routes as the parameter. So all these routes that I created here, in a typical, in the previous two deployments, the routes are turned into a server. So app routes as server, and then I define an undertow server at a specific port number, which in and of itself is pretty cool, that just in one line is all I need to start a server. And that's where one of the areas that HTTP 4K shines is it gives you all different kinds of servers. So again, I'm not super familiar, but there's Netty, Jetty, Apache, there's Undertow, and there's a couple others as well. But in the case of AWS Lambda, you're not using any of this. So I'm defining this, but my main function, which starts the server, is never going to run, because the Lambda function is going to basically only look for this class here. And then HTTP 4K takes over by interpreting the Amazon specific JSON body and redirecting those back to the routes as if they were native. So with just that one line, in the configuration. Now here, in the runtime settings, right, I tell it what Java version, but here's the handler, gateway listener, as opposed to like my main function or something like that. So yeah, so of course, just you can upload your code. I could take my jar file and upload it here, but I've created a deployment action, and it's Heroku. Here's my Amazon version, and when I click here, we have the updated version. And you can see here, it's served on port 0 because Lambda has its own thing. It's not really a web server and stuff. And it has all the same functionality. So again, if I said from Seattle, Washington, it takes a second. It's getting the directions and it's bringing them back. And then here, it gives me my directions. So it's fully functional. It has all the same things as either on the VPS or Heroku. And I think that was like a real eye opener to me, because there is a lot of benefit to going with Lambda, to going with a total serverless solution, in the sense that it's totally scalable. When you have a VPS, you basically, we just went through the holidays, right? So if you're selling something online and you're going to get a massive influx of orders in December, you basically have to pay all year long for a server that has capacity to handle your maximum order time. But then in April and May, when orders are way down, you are still paying for that huge capacity boost, so you don't crash in December. And that's true of Heroku as well, when you decide what level of service you want to get. With a serverless function, it scales up, without a limit, and you're only paying for like the usage itself. So you can probably go through, all those months with a very low or even zero bill if you're not hitting their minimum. And then in December, when traffic spikes, then it scales up without you having to, redeploy on a bigger server, heavier server, start doing load balancing and all that stuff. You don't have to worry about any of that stuff. And like I said, just not managing a server at all is pretty beneficial. The downsides, especially with a HTTP based API, are, serverless sometimes gets bad rap for, a little bit of a slow startup time. So, which can be a little bit of a problem. You don't want to have an extra half a second responding to every single API query that you're going to get. So there's ups and downs to everything. But again, the idea that you don't have to write a whole ton of code to start interpreting all the messaging that is Amazon specific is really a pretty cool feature. It's literally just this one line where you just let HTTP 4K handle the reinterpretation. And if you see here, I've sort of commented it out, but there's same thing for Google Cloud and Azure functions as well. So it should be able to handle those platforms. I started to mess around with it, but then I, was sort of busy and didn't get to like fully implement them and all that stuff. So whether you are starting out and you're not sure where you want to deploy, or you have built something and now for whatever reason you need to move it over, the combination of these two tools, in my opinion, is a great sort of starting point for what you're building upon, a foundation, I guess, because they have total flexibility. You are not in any risk of painting yourself into a corner, isolating into just one deployment option. And as we saw, the ability to make changes on the fly is very, very simple. I didn't show the pipeline from that goes straight to Amazon. That's not built in automatically like it is with Heroku. But with GitHub Actions, I'm able to write this sorry, how do I get it? View workflow file, right. So you basically set up a simple workflow file that says, on every push to my master branch, here's what I want to do. Make sure to get the latest source. Make sure you have JDK set up on Amazon on my Lambda function. My Gradle wrapper, I didn't even go into that. Sorry, this is taking a lot longer than I anticipated that it would. So I apologize for that. And then build with Shadow Jar. And then, I have my access keys, which are hidden in GitHub's secrets section, and the name of my Lambda function and the file to send over. And that's like a community contribution, but basically with just this one file, I have a pipeline that goes straight to Lambda as well. So with those two targets, I've created, what they call CI/CD, continuous integration, continuous deployment. And if I wanted to, on my VPS, I could certainly do that as well with sort of a third-party tool, or probably create a different GitHub action that would have like the credentials to upload that file here. So I showed you how I do it manually, but it'd be very simple to integrate automatically as well. And then every time you make a new commit to your repo, it just sends the new stuff up. So that's kind of what I wanted to get across, is these two packages to me are sort of, real eye openers because of the flexibility that they provide. HTTP 4K has tons of flexibility. I sort of mentioned, it has lots of different servers types that you can create. It also works as a client. It also has lots of testing functionality, whether the testing package of your choice, JUnit, Hamcrest, Cotest, all these things. It works in combination with all those. Same with like JSON serialization, whether you use Moshi or JSON or Jackson, or I like Kotlin X. All those are like already integrated automatically. And it makes it very, very easy to work with, what's called, unopinionated, which other packages are like, yeah, if you want to use me, you have to use this specific package for your database ORM, and this specific package for doing your JSON serialization and stuff like that. And that can spill over into where you can deploy stuff. Again, here, all that is totally up to you. And that's probably what I think is the biggest benefit to that package for writing APIs. So let me just finish up here with the slides. So flexibility is good. Future work, next steps would be, trying it out on Google Cloud Functions and Azure, building that pipeline to our own VPS. And here are different, options for making that happen. And then also DevOps tools. Like I said, I don't have a full web server. I don't have a firewall. I don't have lots of other services running on that VPS, which are also important to get it running. That's sort of out of the scope of this particular talk or this particular tool. You use these other tools to do that, but they are important if you choose to host yourself. And that's me. If you want to read more about this or sort of consolidate it down, I do have this article that sort of covers all this stuff. It's like the third article on the site if you go to cf9.com. And I didn't mention it earlier, but yeah, I'm also sort of in between some stuff. So if there are some opportunities out there, I'd love to, hear about them and consider them and all that kind of stuff. So with all that being said, I know it kind of ran a little bit long and stuff. If you do have any questions, I'm more than happy to answer them or hear what you have to say or anything like that.
So
Excellent.
can you in your code, of course, point to like a location for that YAML file instead of having to explicitly put it in using the D flag when you invoke the Java?
Oh, absolutely. Absolutely. If I chose here in this, config loader builder I could hard code the file like I have here for, this is sort of, if I can't find a JSON string, and if I can't find a file, default to this, to a dev config. And that's what I'm using when I'm doing it locally, but that's a hard coded, file name. And that's right here in my, keep it in my resources. So I can change the port number. I can test this out by, changing any of these parts. And yeah, it will load the new file. So to your point, yes, if I wanted to hard code the file, if I knew for sure, then I can definitely do that. But like I said, it would reduce my flexibility because my VPS, I have the ability to use a file. On those other two targets, I don't have the ability to use the file. I have to use a string, which actually I guess I didn't show here, but on Amazon, they have this configuration environment variables. And that's where I have the hoplite JSON as a string. But if I had hard coded a file name, then I would sort of be isolating myself because I couldn't use those strings. I'd have to come up with a file. And since I don't have access to the file system on either Heroku or Lambda, then I'd be stuck. And if I went the other way, if I said for sure I want just a JSON string to be loaded at runtime, then to your point, my D variable would no longer just be a name of a file. It would be that whole, JSON string, which would lead to the potential for, issues, typos, and stuff like that.
Okay.
But that's a good question. Yeah, for sure.
Excellent. Other questions?
Cool. I definitely appreciate you guys sticking around and paying attention and listening. I hope it was useful. Again, even if right now you're an Android developer, look, every, app has a back end. Every app is connecting to something. So, even if it's not on your agenda today, or even if it's, not part of your responsibility, at some point, you have to consider, hey, how do we actually, build the API? And, myself included, I stuck with what worked. I stuck with Flask for a long time before deciding, hey, you know what? I feel much more productive in Kotlin. I want to use that as much as possible. I want to build my API with that. And then it's just going through that whole learning curve of, okay, what's my, server? What's my, logging situation? What's my configuration? All the things, typical that, when you're starting with a new ecosystem. But I would definitely say that, I'm very glad I did that, and glad that I feel that it paid off. I'm much happier writing these APIs in Kotlin than I was in Python. And, I know Node is popular for writing, backends and stuff, but it just doesn't seem like the way to go for me, at least. So when you get to that point, like I said, the DevOps and the deployment becomes like a big question. And it's like good to know that these tools, it's not that they answer all the questions for you, it's that they leave open all the possibilities for you. So that's the main thing.
All right. Any other questions for Andy? Well, thank you so much, Andy, from the San Diego Kotlin User Group. Thanks for presenting. We really appreciate it. This was
No,
really,
very happy. Thanks.
a lot of really
I
neat
could
stuff. So.
Yeah, just thanks. It just sort of, like I said, something that I sort of was working on and making sense, and I just thought might be, useful, might be interesting, and just happy to, contribute. You, Ian, I mean, are coming up with these, meetings, every single month. I know it's tough, so I want to just sort of contribute something myself. So yeah.
Well, thank you so much. All right. Thank you, Andy.